Good afternoon, dear colleagues. My name is Gulшат Шакирова. I'm Associate Professor of Kazan Federal University, and actually I'm educational psychologist. So today we are going to talk about examining secondary mathematics teachers not knowing the process of problem solving, and we conducted this study in collaboration with Kevin Fierro and Professor Murata Choshanova from the University of Texas at El-Paso. And I'm going to start with ancient wisdom, which could help understand us the notion of not knowing. So, not knowing is a critical state because from it, knowing can follow. It means that not knowing is the first step of knowing something. And at the same time, when a person is in critical state, it helps him to be motivated or to be interested in knowing something. We are going to speak about this study in a traditional way. And the first point is introduction. Not knowing, according to Mason and Spence, it is an underexplored concept defined by an individual's ability to be aware of what they do not know as a means to plan or to face complex situations. And my colleagues, Kevin Fierro and Murata Choshanova, made the research and they made the results in which students have difficulties expressing their not knowing. That's why here in this study we are examining the following research questions. The first one, it is how do students express what they do not know in the process of problem solving? And the next one, it is what challenges do they face externalizing the not knowing? Generally, the phenomenon of not knowing is not extensively researched, but in the works of Mason and Spence and Davis, we have found that the notion of knowing is closely related with not knowing. And it is underlined that the awareness of knowing and not knowing is crucial to successful mathematical thinking. It means that most people have been stuck with a problem and they vaguely can understand of being stuck. As long as their state is superficial, they couldn't influence to the awareness by intentionally using some strategy. It means that students can stare to a blank page or making some repeating, calculating over and over, hoping to break through. So this means that not knowing is an important phenomenon, and an individual must be aware of what he or she do not know to respond to the situation effectively. Strategies to deal with not knowing come most readily to mind if they are richly linked with past experiences. For example, a tutor can assist a situation in which students are getting stuck, and they recognize and they try to be unstuck of this situation, and then they understand that this situation was created by the tutor. Additionally, an individual's awareness of not knowing is informed by their prior knowledge, which is the basis of his or her knowing or not knowing. And that's why we are using the guide frame for examining students not knowing, and the connection between prior knowledge, knowing, and not knowing. The purpose of our study is examining students not knowing in the context of problem solving. Sample consisted of 10 secondary mathematics teachers from the university in the southwestern border region of the United States. Students were enrolled in graduate level geometric reasoning course, and they were focused on problem solving using tangrams. It is a 7-piece puzzle. So we have used such data sources as audio recordings, reflection, and interviews, and data analysis was made by meaning coding and meaning condensation. And now I'm pleased to hand over the floor to Professor Murata Choshanova to present the procedure and results.
Anybody knows tangrams? So that was the tool that we used to study student not knowing. They worked on various geometric reasoning tasks using the tangram puzzle. It seems a pretty easy task, but it's not. If, at least in our study, to construct a square with 7 pieces would require students to do to put a lot of effort to construct this tangram. The students were introduced to the tangram through learning about the shapes, their properties. It helps students to activate their prior knowledge. Then students were solving tasks by constructing squares with different number of tangram pieces. Students thinking aloud while solving the task were audio recorded and transcribed for further analysis. I wanted just to make a little comment on the participation of Kevin, our first author in the proposal. I started working with Kevin when he was a pre-service teacher at the University of Texas, and we have that placeholder, the course with the 0 credits, where undergraduate students can do research with faculty. So he approached me and asked me if there is something that would engage him into studying research in math education with the intention that he would continue in the graduate school at the master's level. That's what he's right now. And as he progressed through his study, he went through several positions. So first, he tried to collect data being a researcher. The second positioning was him being in the study as a subject. And now he moves to the third stage where he comes back and put the hat of a researcher again. So his contribution is quite amazing. But at the little later, I'll introduce Kevin's personal reflections on what he observed with the connection of not knowing to student learning. So we collected 2 major reflections during the data collection. After students work on the activity with the tangrams, we collected post-activity reflections, and we were also collecting post-lesson planning reflections, because again, we were working with in-service teachers, so they would use the activities to teach in their own classrooms. Reflections contained 3 to 5 questions. The participants were tasked to reflect on certain ideas discussed in the class, as well as their knowing and not knowing. Participants' responses were used to analyze how aware they were and their ability to express the not knowing. Data analysis. In order to analyze the transcription, reflections, and interviews, meaning coding and meaning condensation and interpretation techniques were used by Quayle and Brinkman as the main methods of analysis. The first set of analysis consisted of transcription from the participants' thinking allowed responses while voicing their knowing and not knowing. I think that this part is very important. We would pair two students to work together. So one student would be solving the task, another one would be recording the task using the cell phone. And then the recording of the task would focus on two important questions: what I'm knowing while solving the puzzle and what I'm not knowing. So then the recording would be transcribed and further analyzed using those methods of meaning coding and meaning condensation. The second set of analysis was aimed at two reflections in which students responded on what they knew and didn't know at the given time based on the content of the course. Again, meaning coding technique was used to interpret the ideas and make connections to the transcriptions. We used the Saldana's procedure for extracting codes and then grouping codes into certain categories and using categories to move to emerging themes as challenges in student externalization of their not knowing. What did we find? We still confirmed that participants had difficulty expressing their not knowing. Naturally, students were easy to talk about what they know. And not knowing was a type of experience that most of the participants didn't have before. Try yourself, when you solve a problem, try yourself to reflect on what you don't know. It's a difficult task. There are several recurring codes that were observed while analyzing participants' responses, and these codes were categorized in four major themes. The first one is deflection. I'll be going through each one of those themes with the examples of the student responses. The second one is a pressure. The third one is lack of heuristic sense, and the last one is fractured knowledge. The example of deflection. Deflection of not knowing can be identified as an avoidance of challenge when an individual shifts the focus of the not knowing somewhere else beside the aim and the scope of the problem. For example, student responds to those two questions. I know as far as the formulas and all that they are not going to help me. So there is a piece where a student says, I know that. It is more a pattern thing. And then see the shift happens. If students try to do this, it would be the same thing for them. Not talking about herself, she deflects that to somebody else. The student clearly expressed the knowing piece, coded in blue, how instead of being aware of her own not knowing, the student deflects on what she believes others, in this case students, don't know, coded in red. 50% of participants deflected at one point or another throughout the problem solving and reflection. An example of pressure. Participants demonstrated pressure through direct vocalization, frustration, or sense of urgency. Every one of the participants demonstrated pressure at different points during the problem solving and reflection sections. An example, this is ridiculous, laughs. And that's what I'm going back to. Puzzle looks easy, but it's challenging puzzle. They try for a while. They think that they can do that with that simple strategy of trial and error, but that doesn't work. And at a certain point, they get frustrated. Putting these squares together, it's a lot harder than I thought it would be. So the frustration creates that pressure of not being able to find a way to solve a problem. It is destroying my idea of what a square is. maybe if so there's an attempt to do something else. Oh my God, this is so much harder than I thought. So the thinking of the student shifted under the pressure in a completely different direction. Rather than reflecting on what she doesn't know, she tries to accumulate the pressure on herself. I think you did that. Then we can put a little triangle here. I think that's what you had, isn't it? No, this is so frustrating. And the end of this story is student gave up on the problem. The student demonstrates clear frustration and a sense of pressure throughout his thought process as his inability to make sense of the situation. The frustration derives from expecting the task to have been easier than expected. An example of lack of heuristic sense. Again, the easiest and I think the most commonly used strategy at the beginning is trial and error, moving pieces around. Every single participant attempted the first task through trial and error strategy. And the example, I'm going to start with a parallelogram. This is they think it's a weird piece in the puzzle. Just because it has the oddest shape. And I'm going to try to make these sides even, so there is a property involved because she needs to construct a square. And I'm trying to add from there, but it doesn't fit. So I don't know how to get. And see, that's articulation of not knowing. I don't know how to get the sides to be straight without having any leftovers. Okay, now I'm going to start again. I'm going to start with the big piece now. I'm going to put the two triangles together. Very good strategy, but still trial and error. Okay, I'm going to put the two big triangles and try to make everything fit in the middle. Okay, so I'm putting some and they don't fit, but I'm kind of getting the shape, kind of not. We hypothesize that in seeking the solution, students may become tunnel visioned in the process of trial and error, clouding their awareness of not knowing. Well, awareness was not there. So the strategy itself, trying hard with only one strategy through trial and error, makes the student to kind of deviate from the solution. And the example of the fractured knowledge. Fractured knowledge is present when the participant may have knowledge gaps within the given topic, have misunderstandings of the topic, or simply lack the prior knowledge required for the given topic. An example. Okay, so that might be too long. So I think it has to be smaller than 2 square root of 2. Maybe it can be 3. I'll try for 3. So after introducing the shapes, they went through a set of activities as building the prior knowledge and connecting to the properties that they know. So they would start understanding the connection between the side lengths and the area of a square as soon as we negotiate the unit. As soon as you negotiate the unit, everything goes in the direction of the strategy. But still, in this particular example, there is a clear misunderstanding of the number 2 square root of 2 in comparison to the number 3. So the student thinks it has to be smaller than 2 square root of 2. And then she says, maybe it can be 3. The participants believe that 3 is smaller than 2 square root of 2. I think the square root of 2 is missing there. And carries on without a second thought, guiding her down the wrong path. So we're coming to the end, I think, Kevin reflection, connections to learning. That's where Kevin was observing and interviewing 2 students out of 10 who demonstrated a good progress during the course. What Kevin says, the data gathered from the students clearly demonstrated the difficulty students faced when reasoning with the tangram activity. Throughout the course, 2 students stood out who displayed almost complete mastery of the tangram. They were interviewed as means to better understand the progress made. Both students expressed their dislike for having to express what they didn't know while solving the tangram task. One of the students stated that the question of what don't you know seemed like a really simple question, but in fact found it to be really hard to answer. Nonetheless, an important factor is that these students made an attempt to express their not knowing. This contrasts directly with those who made little or no attempt at expressing their not knowing or simply lacked the ability to do so. Those who could not clearly articulate their not knowing seem to have struggled more extensively with the tasks. While both parties attained new knowledge from the course, the results indicate that those students who more actively sought to express their not knowing gained a better understanding of the concept. I see 0 there, but that's the last slide, discussion and conclusion. Mason and Spence make it clear how important not knowing is as a first step for knowing to occur. So in the study, we focused on examining how students are expressing their not knowing. Findings suggest that in most cases, the participants had difficulty expressing their not knowing. The recurring themes came to light from analyzing students' transcriptions, reflections, and interviews. And again, the deflection, the pressure, lack of heuristic sense, and fractured knowledge were the major themes we were able to emerge from the analysis. Understanding these themes can assist in minimizing the problem while maximizing the potential of not knowing as a lead to knowing and understanding. Findings suggest that students who were better able to express their not knowing demonstrated a strong understanding of the concept at the end of the course, and findings of the study might serve as a stepping stone to further researching the construct of not knowing, as it may potentially link to more effective and efficient student learning. Thank you.
Hey, thank you so much for the wonderful presentation. So definitely help us to know what students not knowing from presentation. I think we can take a few questions from the audience. So maybe we invite our presenters to sit here.
All right, thank you.
Yeah. Hanula? Oh, it's okay. Yeah.
Thank you. Thank you for you to introducing us. I know Mason's work, but I had not encountered this concept before, and it's very John Mason thing about the not knowing thing, very much his style. I like the thing you said. I started to think that the problem you see for students to express them not knowing, and also that those who are able to express, they actually further on the road, that it might be worthwhile to distinguish 2 types of not knowing, like not knowing and being able to express what they don't know, and the stage before that when you're not able to express what you don't know. I don't know if that is something you already thought, or if you have any ideas about that.
Until we record, I think, we don't know what they don't know. So then the problem is that we were trying, maybe the disadvantage of the approach, and that was Kevin proposed. Now we're changing slightly the format of the data collection. So Kevin proposed saying, how do we know what students, and how do we extract what students don't know, right? So the thinking aloud protocol came to his mind saying, let's do that, and we record them while they talk out while solving the problem. So this way we could at least see if they have difficulties, but what the difficulties, what the challenges are in expressing, right? He's changing the protocol right now, and he's using a format with a problem stated above, and then 2 boxes where students can write down what they know and what they don't know. He's collecting the data, and we're trying to see if I think the theme of pressure came with the recording itself, because they were recorded by the peer, and they felt the pressure. So writing it might help us to see it from. We're trying to remove a pressure, at least from the study, so they could write it down, and we could analyze the written responses, what they know, what they don't know. But we'll see what happens.
It's a bit difficult, so I'm trying to, find a place. Okay, good. Thank you first for your presentation. It was very impressive. I really liked the topic, and it was the first time I was hearing about that. My question was more about the definition of not knowing, because when you have a fixed solution for a question or for a challenge, it could be mathematics challenge, science, and so on. So it is easy to define the area of not knowing for someone. But what about if you have multiple solutions for one question, one challenge, or one practice? I give you an example. Imagine that you are in a classroom and there are 2 students and 1 teacher. So a student A says that, okay, I have a solution A1 for this, for instance, question. A student B says, okay, I have solution 2 for the same question. And teacher has in his mind solution number 3. So they have 3 solutions for one question. So the not knowing definition of the first student from the second solution, of course, is more than the not knowing of the A student about the first solution, because his own solution. Of course, it has a more knowledge than not knowing. So how we can control for this? Do you have any suggestion for this kind of confounding variable? So when there is more than one solution for a question. Thank you.
Let me clarify. I think what I'm hearing is student response to somebody else's solution, right? That's where you want to know whether students can express their his or her not knowing.
I think he speaks about the criteria, something like that. Yeah, to define not knowing.
Definition.
Yeah.
How do we know if the student is articulating not knowing?
Okay, I rephrase it. I mean, I'm trying to say when there is more solution than one, okay, and then the not knowing of someone doesn't mean that the person doesn't have enough knowledge about the solution. Because the first solution might be weird to second student. And the second solution might be weird for the first one. And of course, because they have their own solution for the question, for the challenge. And of course, they have different level of not knowing for the same solution, for the same question. So how we can control for that? I don't, is it clear now? Yeah. I know it's a bit, it's complicated, yeah.
Well, I'm still trying to understand the question. In this particular study, I think we were focusing on individual students not knowing, or individual students' externalization of not knowing, right? And that means that the not knowing comes from that individual student's problem solving and understanding the solution. So the students are not reflecting on other solutions or other methods of solving the problem. They focused on what they don't know. And they try to externalize that, whether it's vocally in this study or in written response that we'll be using in our next study.
So for instance, there is a X problem, and I don't know, okay, about this X problem less than the solution B for the same problem. I don't know, is it clear for you or not?
So we are maybe I can explain.
Yes, okay.
We are not speaking right now about the right solution, but we are speaking about not knowing, the externalization of not knowing.
Exactly. I mean, I'm talking about the same thing. I'm asking about when there is a not knowing level, okay, and there is multiple solutions for the same problem, for the same issue, for the same exercise.
But the student might not have multiple solutions, right?
Well,
So
no,
the student would
yeah.
be using her own solution and externalizing what the student doesn't know in that particular solution while she's trying and struggling to do that, right? So I think the case of another method or another solution is not present. See what I'm saying?
Yes, yeah.
So the student is not reflecting on her or his not knowing of another solution, but the solution that she is working on or she's trying to come up with.
Maybe we give time
sure.
for
Thank you very
others,
much. Thank you.
people to ask questions. Yeah.
Thank you. Just a comment that I like very much this culture of not knowing that you try to nurture, and because we often ask students, I can't tell me what you don't know, what you don't understand. I don't see response, so I can't go into how they find what the problems are. So if they really have a culture to revealing their problems, of not knowing, it will help us all to get better in teaching, I think.
All right.
Yeah.
Thank you.
The lady at the back. Yeah.
I would maybe follow up what Donnie said. I think the implication part of the study, and we're not there yet, helping students to be aware of what they don't know. And I think that study might, and Kevin is thinking how to design that study, the implication of being aware of what you don't know.
Yeah, thank you very much for the presentation. My question is, along the continuum from not knowing to knowing, you have coded different classes like deflection, fractured knowledge, etc., 5 classes. Are there any instances that some students not wanting to know? This is called stagnation.
Not wanting to express not knowing?
Stagnation. They don't want to know, or I'm done. I can't do something like that. Have you captured?
Gulshad is collecting. Actually, she collected the data at Kazan Federal University with about 40 pre-service teachers, math pre-service teachers, and we were using a slightly different set of problems. We used the connected algebraic problems. They go, the 3 problems, they start at the numerical mode, they move to the second one at a semi-abstract mode, and then they move to the abstract mode, right? So the same contextual task, but at kind of extended. So what we're trying to see there, and I'm kind of moving from that study to the next phase of the study, we're trying to see that if the task is too easy, there is nothing to say about not knowing. So I just simply solve the task. I'm ignorant about not knowing because this task is solved, and I think it's what you're trying to ask. But as soon as we increase the level of difficulty of task, then you see more student responses on externalizing not knowing. And then as soon as the task becomes too complex, we see, again, the decrease in the not knowing responses.
Thank you.
I just have one observation, and I'm seeing two aspects here. On the one hand, you cannot know what you do not know. On the other hand, you can feel, I'm stuck. So there are two different things here. And what I'm interpreting is that when you say not knowing, you are meaning, I am stuck. Because how can they know what they do not know? That's my question.
Yeah, it's, let me see if I have that matrix here. From a philosophical standpoint, there are 4 stages, and probably you have seen this matrix. So if we look at the horizontal external world, known, unknown, and we look vertically at the level of awareness, not knowing, knowing, there's 4 quadrants. I know what I know. The people who do research in knowledge management, they consider that as a knowledge exploration strategy. I know what I know, and I can express that. The second quadrant, when you move to the upper right, I know what I don't know. That's what pretty much we're trying to see, if they can externalize what they don't know. The 2 quadrants down, I don't know what I know. That sounds pretty interesting. I don't know what I know. And the last one, I don't know what I don't know. That's where Norma is coming from. So, of course, when we, again, I'm referring to that second study with the data collected on pre-service math teachers, that becomes the ignorance. And that becomes evident when the task is too easy. They solve it, I don't know what I don't know. The task is solved, I know it. So you increase the level of the task, and that's where we see a little more responses on what I don't know.
So first of all, you have to be stuck with the problem.
But this stucking point, I think what Norma refers, it's a more affective, emotional stage of me being stuck. That doesn't mean that I don't know, I know what I don't know. Mason uses two nice examples, and I think that's the one that you were trying to bring when he describes the situation with a student who's stuck at the problem. So there's no way, it's what Kevin described as tunnel vision. So trying to use the same strategy over and over doesn't work. And that also prevents from a person to explore other possibilities. That's what the stuck is, being stuck. But I'm trying to perhaps distinguish between being stuck and having that pressure of being stuck to the situation when a student or a person could be aware of his or her own state of trying to get out of that situation through awareness of what she or he does know. I hope I at least approached the question that you posed.
Okay. The lady, yeah. Yeah, you, yeah. Oh, sorry, yeah. Hanula first, yeah.
Yeah, I have the knowledge matrix is partly responding to my question already before I posted, but I would like to hear you maybe elaborate a bit more why you don't speak of metacognition, because what you're telling here could be metacognition. I think it's deliberate choice on your side not to talk in terms of metacognition, so I would like to hear how you see your framework different from what metacognition and meta-knowledge is addressing.
The literature on not knowing is very limited, and you would probably already notice that Mason and Spence work, the only one that we could use at this point to at least start approaching the problem. So we're trying to, at our next stage, to see what Mason talks about knowing. And he extensively talks about knowing. And he distinguished between 3 types of knowing: the responsive, the active, and reflective. So I think the reflective part, that's the part of metacognition, might come after the fact, after the solution is complete. So I can go back to my task and start reflecting. So now you're saying, what didn't I know at that particular moment? But we were trying to focus on the process while the student was solving the problem. So we were focusing on the active not knowing rather than reflective. I don't know whether you can call it metacognition, but I think the awareness of, while you solve the problem, the awareness of what you don't know might help you to approach the problem from a different perspective. But that's the active not knowing.
Okay. Thank you for your, it's a very interesting topic. So my question is, the not knowing strategy is really, really different what we are used to. So my question is, what do you think the easiest way to integrate this strategy into our life, or like into our education system? Because it's really, really different.
That's what I think Kevin tried to do the observation on the 2 students out of 10 who made the progress in the course. So those 2 students put a lot of attention to try to think about what they don't know. On the first task, the very first task, they expressed that frustration of not being able to express not knowing. But since we used it throughout the course several times, by the end of the semester, even though they say we don't like the question asking us to express what they don't know, but we were observing on the case of those 2 students, they were building an awareness of that, because we keep asking what you know, what you don't know, what you know, what you don't know. So one of the students, Christy, she became so addicted to that approach, even that she didn't like at the beginning. So she decided to use that approach in her own teaching and see how she could develop a culture so the students can be aware and reflect on what they don't know. So it's a process.
Okay, I think this is probably the last questions, okay, from this gentleman.
Thank you for your brilliant research and presentation. I've got 2 questions. First question, as far as I've got, you've investigated that there are 4 major types or strategies of don't knowing expression.
Challenges. 4 different challenges.
Yeah, 4 different, some people express they don't know in such a way, some people express they don't know in another way, and so on. There are, a limited number of these ways you've investigated. I am very interested, have you noticed some connection of those ways with gender, age, psychotype of the students? That's the first question.
That's the first question? Yes, the sample was small, only 10 students in this study. We're trying to look at those associations with the sample of the pre-service math teachers. We have a little larger sample with a better distribution by gender, by, I think, by even we collected GPA.
Yes, but we don't have any differences according to gender, for example, but we have differences in GPA and...
the mathematical GPA, right? Not the general.
Yeah, mathematical GPA.
So that is a promising piece. The students who, let's say, who have high GPA in mathematics courses that they took in pre-service program, associated with the ability to externalize not knowing,
So,
but not any promising associations with gender and other
one of
variables.
the most interesting results of quantitative study, we compared psychologists and mathematics per-service teachers, and we find out that psychologists are more reflective. And they are, I don't know why, but they solve these tasks easier and they can reflect better. Maybe it is a professional thing, but we are in process of interpreting it.
Thanks. One short last question. Okay. In terms of strategy of expressing not knowing, what's the most productive strategy in measuring time consummation to perform the task? What's the strategy of expressing not knowing is more is the best in terms of I solve this task faster?
We haven't. That was not the focus of the study. I think we were trying to examine challenges that the student have in expressing not knowing. Honestly, I don't know what would be the best strategy to express the not knowing. I don't. That was not the.
I mean, statistically, what's the best strategy? Have you measured it?
We didn't look at that. We didn't look at the strategy.
It's impossible to find out.
Okay, thank you.
Yeah, okay. Thanks again for coming. I think that's the end of this presentation. But you may continue your discussion with the presenters during the break. Okay, thank you.